Oh, you're finally awake. Let's continue implementing BSTS. I have such wonderful new model components to show you. Recall the local linear trend model, which we present here. Y sub t is our data, mu sub t is the local level, and nu sub t is the local linear trend. This model will hopefully account for the linear trends, such as those seen in our data. Fitting this model is just like fitting the local level model. The only difference here is that we use add local linear trend instead of add local level. Let's skip ahead and view the forecast plot. Just like with the local level model, we forecast 1 year ahead and plot the last 3 years of the original series. This model attempts to capture the trends at the tail ends of our time series. Without any data to steer it, our model forecast drifts the temperature toward boiling and beyond. Does this model sound reasonable to you? All right, I hear you. Let's model seasonality. Tally-ho! In our case, S is equal to 30. We specify this in our code by setting the in-season parameter to 30. The local linear trend component is specified just as before. Then we include a seasonal component using the addSeasonal function. Let's take a look at our component plot. Our component plot provides us a glimpse of how our model will behave. Trend component appears to be roughly level, as is our data, and the seasonal portion is, well, seasonal. Very promising. Now we can see what our forecasts look like. Our forecast is seasonal. Do you see how the air bars move up and down with the seasons? This is what our previous model failed to characterize. This model is doing a much better job of capturing the general pattern of our series. Here is something new. BSTS provides a plot that is useful for comparing several models. We use the compare BSTS models function by passing a list containing the 3 models we created so far: the local level, the local linear trend, and the local linear trend with seasonality. Based on this plot, we might be tempted to use the local linear trend, seeing it has the smallest error. But we know better. Use this plotting tool as guidance, but know that this does not account for forecasting. Based on what we saw in the forecast plots, the linear trend with seasonality does a much better job at capturing patterns evident in the sea surface temperature data. I would advise you to use the local linear trend model if you wish to interpolate within our data. For extrapolating, I would recommend the seasonality model. Speaking of forecasting, I predict us encountering other data on this road. I here do tell stories of multiple layered sea temperature data lurking in these very woods. In the event that one makes an appearance, we can model the multivariate data set with the regression component as well. But hark! What is that rustling in the underbrush? Could it be the fabled Set? I'm going to sneak up on it. Stay tuned.